Now we move on towards a special kind of functions called as recursive functions. What are recursive functions? Why are they more interesting? The functions we have seen so far are ones which get prototyped, get defined and then called by some other statements in your program. But these are functions that call themselves again and again. You might ask me a question, sir, you told us that a function cannot be defined within a function, then how a recursive function becomes possible? I have told you that a function cannot be defined within a function, but I have never said that a function cannot be called within itself. So this is a typical function that calls itself again and again. It does not wait for someone else to call it, rather it calls itself again and again. So what are the peculiarities or what are the needs of a recursive function? Any recursive function should always have a base case. What is a base case? Base cases are something that are reserved as assumptions valid for that particular application. So every recursive function should have a base case. What is rule number 2? Every progression in the program thereafter should be towards the base case. What do you mean by it? I have created something as an assumption for this application. From then on, I will have some progression in my function. That progression should always be focused towards this base case. I will tell you the need as we get into some examples. Then the third important rule is to avoid duplicates. What do you mean by avoiding duplicates? Wasting of time in reinventing the wheel happens to be known as avoiding duplicates. There is no need in recomputing something which has already been computed. So that stays as the third rule in a recursive function. Try to avoid production of duplicates. And the last one happens to be make valid assumptions. What do you mean by it? Depending upon the application, try to fix your assumptions. Make useful assumptions that would make sense towards the application. That is what we do call as making valid assumptions. Let us now take a simple case where we need to compute the factorial of a number. What is factorial of a number? We say that factorial of a number, say 3 factorial is termed as 1 cross 2 cross 3, that is start from 1 and move on till the number, that is you have a product of all those numbers between the number and 1, then it stays to be the factorial of a number. Let us now try to have a simple recursive function that computes the factorial of a number. How can I have a recursive function that computes the factorial of a number? Say I would like to have imagine I want to calculate factorial of a number n. Now this is the name of the function, this is the parameter I would like to pass towards my function, and imagine int is the return type of my function fact. How would I define this? The very first rule that I have to have is my base case. What is the base case? In my example, I check if n equals 1, I will return 1. This is my base case. Whenever I find this n to be 1, it means that I am trying to compute factorial of 1, which we do all know as the value is 1. So whenever n becomes 1, I try to return 1. What is that I do if it were not something like this? Then I say else f of or fact of n equals n star fact of n minus 1. You just have a look at this. Now I want to find out 3 factorial. What happens here? Now I would pass in 3 instead of n, which means the value of n now becomes 3. It will flow into this block where this won't be satisfied, because of which it will flow into this line where fact of 3 would be something Factor of 3 would be something like 3 into factor of 2, which is again a recursive call towards the same function where the n value now becomes 2. When it flows onto this particular block, n is not equal to 1, so the else but get executed, then factor of 2 gets evaluated as 2 star factor of 1. So this becomes 2 star factor of 1. If you take this out, what is n now? It becomes 1, by which this particular block gets satisfied and the value 1 gets returned. So the value for this call happens to be 1 and this gets evaluated as 3 factorial. This is how a factorial program gets executed on a recursive basis. Now let us try whether we have satisfied those rules. Number 1, I have made use of a base case. Then the progression in my function is always towards my base case. Just think, while I have not had n minus 1 here, rather I had something like n plus 1. What would happen to the entire function? It would keep on incrementing rather than diminishing towards a particular point. That is the second point what we made as every progression in the function should always be made towards your base case. Then I would like to explain the third important strategy that we have towards recursive functions, that is trying to avoid duplicates. We all know that a Fibonacci series is a 1 where any term is a summation of its previous 2 terms. Imagine I have a core block in recursive programming where the nth term in a Fibonacci series is f of n minus 1 plus f of n minus 2. Imagine I want to compute f of 5. So how does this expand as? This expands as f of 4 plus f of 3. When I keep expanding this, this becomes f of 3 plus f of 2 along with f of 2 plus f of 1, where I try to recompute f of 2 twice. This should be avoided because I had already computed f of 2, so why should I waste time in computing f of 2 again? This is what we do stress as the third point in recursive functions, that is try to avoid duplicates. If you have a recursive function in this way for computing a Fibonacci series, then it is a poor use of recursive functions. The last point we do have about recursive functions is make valid assumptions. If it were a Fibonacci series, the assumptions I would make are f of 1 equals 0 and f of 2 equals 1. I may not make these assumptions in case of a factorial of a number program which makes use of recursion. Then it will be petty and silly to make use of these 2 assumptions in factorial of a number. Rather, I cannot use if n equals 1, return 1 in case of my Fibonacci series. So make valid assumptions in terms of all your recursive functions. So the core behind recursive functions is: number 1, have a base case; number 2, make your progressions towards the base case; number 3, try to avoid duplicates; and point number 4, make valid assumptions. You might ask me a question: sir, we do have iterative blocks. In what way are recursive functions better than iterations? Repetition in iteration is an explicit loop, whereas in recursion it is repeated function calls. What is termination? In iteration the loop condition fails. In recursion the base condition gets recognized. I hope you can better understand these 2 things. What is termination? In case of an iterative block, whenever the condition fails, you come out of the block. In case of recursion, the base case gets recognized and you come out with a specific value. Both can have infinite loops, but a choice between performance and a good software engineering happens to be the difference between an iteration as well as a recursion, where recursion comes at the top. So now we have visited a variety of functions that we have in C. A quick recap about all these things would be how to have a function, how to have the advantages of a function recognized, how to have function declarations, how to have function prototypes, how to have function definitions, how to have the different ways of calling functions, and then a special case of functions what we call as recursive functions. With this, we come to the end of a session on functions.